Hello, and welcome to Backer Breaks It Down. In this episode, we're going to look at composite functions, specifically evaluating composite functions. But first, what's a composite function? Okay, so a composition of functions are two functions connected by the fact that the output of one is the input of the other. Okay, and we can express a composition in one of two ways. So I can write like f of g of x like this, or I can, kind of looks like fog, but that symbol just means composition. And basically what happens is the function on the inside is put into the function on the outside. That's kind of what like this little graphic is illustrating. The inside function goes inside of the outside function. Could go back to like this little picture here. So our two functions are like toast and eggs. And so I can either put the eggs inside of the toast for f of g of x, or, and I don't know why I would do this, I could go egg, toast, eggs. So I could put the toast inside of the eggs. But that's like what this is saying when they say put the inside function into the outside function. So put the eggs into or inside of the two pieces of bread. Or put the pieces of bread inside of eggs. Like I said, I don't understand that one. I've never done that. All right. So let's first look at evaluating. Now we have evaluated functions in the past. It's pretty easy to do. It's just a matter of substitution and calculation. So when you're working with a composition of functions, start on the inside, work your way outside. So in number one, I have f of g of 4. So I'm going to start on the inside. This says g of 4, and I'm going to evaluate that. So the function g is 2 plus the quantity x minus 1 squared. So g of 4 would be 2 plus 4 minus 1 squared. And so I would calculate this, and I get 11. All right, so I know that this is 11. Okay, so I'm going to take my answer of 11 and I'm going to plug it into the outside function. So basically, this right here is now f of 11. Because the inside, which was g of 4, we did that, we got 11. So now I'm just going to figure out what is f of 11. F is the function 3 plus the square root of x plus 5. So I'm going to go 3 plus the square root of 11 plus 5. Okay, and I get 7, and that would be my answer. So we're starting with the inside, and we're evaluating the inside. So in problem 2, f of -1, I need to figure out what that is. So the function f is 3 plus the square root of -1 plus 5. So I do my math, and I get that this is 5. And so then my problem has now become g of 5. And that's what I want to evaluate next. G is 2 plus, and then 5 minus 1 squared. And so I do the math, and I get 18. And that's my answer. So we've evaluated functions before. When we evaluate composite functions, we're just doing it twice. Evaluate the inside, plug that answer into that outside function. Now I can do this with a set of ordered pairs as well. So in number 3, it says g of f of 4. So start on the inside, f of 4. All right. So f of 4. Okay. So the answer to f of 4 is 1. Because when x is 4, f is 1. So then this is now g of 1. g of 1, find it in the set, is right here. So this has an answer of 2. Start on the inside, g of negative 2, g of negative 2, okay? This here has an answer of 4. So now my problem is f of 4, f of 4. So the answer is 1. Number 5, so if you're like, what? Because it looks different from 3 and 4, honestly, it's not that bad. We just have one additional step, okay? So we start on the inside. The inside says f of 3. So f of 3, okay? And that answer there is 5. I'm going to use a different color since there's more going on here. So now we have f of g of 5. All right, so once again, start on the inside being g of 5, right? So g of 5, okay, is 5, right? So I still have that f on the outside. I'm almost done. F of 5. F of 5 is 0. That's my final answer. So you're just kind of like starting on the inside, evaluate, plug in, evaluate, plug in. Now I can do this as well with a graph, okay? So when we look at graphs, remember, they're telling us the x value. We need to use the graph to find the corresponding y values. So we start once again with what's on the inside. So this is g of negative 1. So g is my graph that's in red. I'm going to find that point. So the point's right here. Okay. G of negative 1 is negative 3. So this is now f of negative 3. Okay. So I'm going to use my f graph, which is in blue. I'm going to find where x is negative 3. It's right here. And the y value is 1. So the answer to number 6 here is 1. So number 7, start on the inside, g of 1. Okay, function g is in red. Find that point. Here it is. So g of 1 is negative 5. So now this is f of negative 5. Find it on the graph. F is in blue. So f of negative 5 is right here. And it corresponds to a y value of 3. So 3 is my answer. Number 8, start on the inside. F of 0. F is in blue. Find that point. So when x is 0, y is 2. So now this is g of 2. Find it on the graph. G is in red. Find where x is 2. The y value there is negative 6. Number 9, start on the inside. F of negative 1. F is in blue. Find where x is negative 1. It's right here. So when x is negative 1, y is 1. All right. So now this is g of 1. Find that point on your graph. So when x is 1, g is negative 5. So composite functions, evaluating them is pretty simple. If you're using the algebraic formulas, simply substitute and then evaluate, which is merely calculating, okay? If you're using a graph, you're going to have to find the point on your graph, and the answer to an evaluate is the y coordinate, okay? But basically, we start on the inside of our functions, we evaluate the inside function, plug the answer into the outside function. And that's how Becker breaks it down.